Hello. So today I'll be presenting a brief tutorial of the Nowcast-It or Shiny application. So the Shiny app interface I will be presenting today facilitates the obtainment of reporting delay adjustment curves without requiring any previous programming or coding experience. So it presents a graphical interface that utilizes a frequentist approach to provide robust reporting delay adjusted case incident estimates, thereby allowing users to account for the underreporting of cases that often occur during disease outbreaks. So to get started, what we need to do first is navigate over to our GitHub page. And the link to the GitHub can be found in the YouTube video caption below. And then once we're here, what we're going to do is click this code button and then download zip. So what this does is downloads the function, the R code data, the Shiny app, and this load data functions copy.r files to our local system. Once that's downloaded, what we're going to do is go find that zip folder. So for me, mine goes to my downloads. And as you can see, I have the zip or downloaded zip folder right here. And then what you're going to want to do then is once it's downloaded, you're going to want to click through until you find the Shiny app folder. And then the Nowcast-It Shiny folder. So this Nowcast-It Shiny folder is what we will be working with today. And what you want to do then is move this Nowcast-It Shining folder to somewhere that's easily accessible on your computer and outside of the zip folder. So I have already done this. So as you can see, I have my Nowcast-It Shiny folder here. And then let's take a look on what inside of the folder. So inside the folder, what you'll see is multiple R scripts. You'll see an R project, and then you'll see this tutorial folder. So let's take a look at this tutorial folder first. This is where we can find the data that I'm going to be talking about and using today, and is an example of how you can set up your data when you want to apply this toolbox and this R Shiny that we're going to talk about today to your own research. So for this particular Shiny app, data can be stored in the form of case or death count data. In particular, for this tutorial, we're going to be working with case count data. And as can be seen here, each case should be a separate row in the data set. So each row represents a specific case that occurred during the outbreak, where the first column should correspond to the date or week of symptom onset in the outbreak, and the second column will correspond to the date or week of reporting. So for example, this one here represents the week of symptom onset in the outbreak for this case. And the 17 represents the week that the case was actually reported. So please keep in mind, if you're using the dates of onset in reporting, instead of using these week numbers, you want to use the 5-digit number representing the date of onset. So how you can do this is in Excel, where you could have this data loaded, is right-click and then format your date as a number. However, for this example, we're going to be using the week numbers or the week of within the outbreak. And one last thing, the file that you end up loading into the Shiny app must be a TXT file. The Shiny app does not take any other type of file, only TXT. So now that we've taken a look at the data, let's open up our Shiny app. So to do this and to make sure everyone's working directories are set up properly, you're going to want to click on this Nowcast-It Shiny project. And what this should do is automatically open up RStudio and load the necessary files, working directories, everything that you're going to need to work with this today. So as you can see in this bottom right-hand section, we can see everything we were just looking at in our file explorer. We have all of our R scripts, that tutorial folder in our project. The only R script we care about is this app.r file. So we're going to open that. And as you can see, there's lots of notes in here, lots of code. You don't need to do anything except open up the app.r file and then click Run App. And if you're running this for the first time, you may run into a little bit of delay as packages are downloading. However, if you see this page pop up with this Nowcast-It, our sidebar, and then some empty boxes in the center, you know the app has loaded correctly. So the first thing we're going to do here is load our data. So we're going to go to this choose a data file and click browse. And then we're going to navigate to our data. So mine was in downloads, Nowcast-It Shiny tutorial, and I'm going to load the March 3rd, 2019 data. So I have this data loaded. And in this case, I'm working with weekly data, so I'm going to mark this as weekly. And then I'm going to enter the start date of my data. So this is in the outbreak, what is the first week of data? What is that actual date? So for me, that is in May. So it is May 13th, 2018. And what you'll see as soon as you put that start date in, you're going to see a bunch of things pop up. However, before we cover what these things are that we're looking at, let's talk about this last window M. So the M corresponds to the amount of time or the number of most recent time points according to the reporting date in which we believe that the reporting practice has been reasonably stable. So essentially, this is how many time points have to go by for what is being shown for the cases or death counts for it to remain stable and not be changing due to reporting delays. So right now, this defaults to the length of your data. So this is defaulting to the 44 data points that we have. So as soon as we change that window M, or again, the number of most recent time points in which we believe the reporting practice has been reasonably stable, we'll see our output shift to reflect that change in that window. So now what we're taking a look at here is we have our reporting delay adjustment curve, and then we have multiple tables we can take a look at down here. So let's take a look first at these tables. So the first thing we see is this reporting delay adjustment. So this table right here is what's plotted up in the above graph. So we see what is the actual reported. So this is what was reported by our source. We have what is the delay adjusted, and then the lower confidence limit and the upper confidence limit for this. So we can see this reflected up here. So this black line is our reported epi curve by date of onset. The red is our delayed adjusted epi curve by date of onset. And then the dashed in solid green lines represent our confidence limits. So we can edit this figure by clicking figure options. So there are quite a few different manipulations available if you want to change colors, manipulate the dates. So that is an option before you download your figures. And then you can also click this download figures button and you have multiple options here as well. So moving back down to the table, we also have our one step ahead predictions of data, our estimated reverse hazards with those confidence limits, our right truncated probabilities, and then also our matrix for probabilities. And all of these tables are available for download. So what you do is navigate over to this download table button. And then you can download each individual table as a CSV file to the folder of your choosing. So the last thing I'm going to talk about is our available metrics. So we are able to evaluate our delayed adjusted epi curve against what actually happened, so against some truth data. And how we're going to do that is navigate over to metrics, And then we need to choose our data file. So we need to indicate what this truth file is. And then to do so, you click this browse button. But before we do that, let's take a look at what the data should actually be structured like. So again, I'm going to go back over to this tutorial folder and then click on this truth April 22nd. All you need in this truth folder is one column corresponding to the true incident at each time point. So the first row of this data must correspond to the first time point available in the delay adjusted curve. And some other things here, there are no required naming schemes for this file, other than it must be a TXT or CSV file. So this is what our truth data looks like. So navigating back over to the dashboard, what we're going to do is click this browse button, load that data, and then you'll see our metrics pop up. So we can see our MAE is 1.66. So our MAE is our mean absolute error. Our mean squared error is 15.13, and then our 95% prediction interval coverage is 95.35. And then we can also download the metrics to our local system by clicking this download metrics file. So that is a very brief overview of the Nowcast-It R Shiny application. If you have any questions or concerns, please navigate over to our GitHub and let us know or leave a comment on this video. Thank you for listening.